Ground effect, what is it? So when we come into land, we feel a massive boost in performance on our wing. I have a couple of things drawn out here. I have a wing with high and low pressure. Now these high and low pressures are causing wingtip vortices. Wingtip vortices are caused by high air pressure wanting to go to low pressure, which can escape until the end of the wing. So that's going to vector around it and hit what's called our downwash. Now our downwash is just our relative wind at the trailing edge. So we can see that the downwash is slightly steeper, and that's going to bend our lift vector backwards. So we have our ideal lift vector up here and our actual lift vector here. Now in the middle, I have two red lines. That's going to indicate our total amount of induced drag that we're creating. Now this is before ground effect. It's a lot of induced drag. Now let's say we're coming into land and we start rounding out. But we have ground now coming into view. Now this is about 1 wingspan in distance above the ground level, and that's going to cut off our downwash and some of those wingtip vortices. These wingtip vortices are now reduced, and this downwash is now reduced. That's going to shallow out our downwash. It's going to move it up to somewhere around here. And whenever our relative wind moves, our lift acts perpendicular to that, so it'll move with it. So I'm going to draw now our lift vector in ground effect, getting slightly closer to that ideal lift vector. And as we can see here, we have a massive loss of induced drag. All of this is lost induced drag, which is going to boost your performance and allow your wings to fly much better closer to the ground.